And so then I wanted to talk about this other FRQ. So this FRQ, the reason I wanted to talk about this one is because, like the last one, it relates very much to what we're studying right now. But it also requires some math. And so I wanted to kind of talk about the math a little bit because I've gotten some questions about the math. So anytime we have math on an FRQ, you must show your work. Okay, you can't, even if you have the right answer, sometimes you don't get any points for showing the right answer or for just having the right answer. Sometimes you get points for having the right answer and then points for showing your work. Sometimes you have to show your work and have the right answer in order to get points. But you never get points for not showing not showing work, right? You can never get full points anyway with not showing your work. So it's really, really important to show your work on the FRQ. So, and I also want to show how another example about how a math FRQ doesn't necessarily always have math. The whole thing isn't math. So there's usually, even if you say, whatever, I'm not doing math, I can't do math, whatever, there's still something that you can do. The whole thing, like not all the 10 points come from math. So here we go. This one says that coral reefs are produced when corals acquire calcium ions and carbonate ions from seawater and deposit solid calcium carbonate to form their exoskeletons. Scientists are concerned that relatively rapid decreases in ocean water pH is going to hinder the deposition of CaCO3. Basically, CaCO3 can dissolve, acid will dissolve it. And so it'll basically dissolve the corals. And so it says the graph above shows the amount of CO2 dissolved in ocean water and ocean water pH shown in parentheses 1850 and the predicted changes through 2100. Okay, so this was I think this was written in 2011, but they usually write them a couple years before. A good rule of thumb, if you want to, for the FRQ to kind of see what they're going to talk about, at least for as far as current events, is it's usually stuff that's like 2 to 5 years old. So something that's happening like right now, a current event, would not be something that they would put on the AP exam. They'd put something that's probably like 2 to 5 years old. So if you look back at, things that were like 2 to 5 years ago, then those would be the kind of current events that you'd see in your FRQ. So anyway, this is what the graph looks like. This is the background information that they give you. Okay, you can see the pH is decreasing as the carbon dioxide is increasing. Okay, so then they want you to explain how the amount of dissolved CO2 in the ocean results in a decrease in the pH of ocean water. So basically, you need to explain like what's forming, right? Carbon dioxide basically reacts with ocean water and forms carbonic acid, right? Which you show the equation, or you could do the words. Again, you see how it's pretty chemistry based. I like to do the words part. So we could say when CO2, you could say CO2 or carbon dioxide, it doesn't matter. And the specific acid, I'll write it here just in case you're one of those folks that likes to remember that. It forms an acid, which is carbonic acid right here. So that's basically what causes the decrease in the pH, is because CO2 is reacting basically with carbonate in the water and forming, or reacting with water and forming calcium carbonate, acid, hydrocarbonic acid. Jeez, I am like really struggling tonight. So it forms the calcium carbonate, and then you get the carbonic acid. Sorry, I just had all these like messages coming in. Reading those instead of paying attention to what I'm doing. So explain why the movement of carbon in the ocean has been increasing since 1850. Okay, so basically Why has carbon in the ocean been increasing since 1850? Basically since the Industrial Revolution, right? Now you don't have to write this part. I'm just kind of using it to explain. So basically since the Industrial Revolution, we've been releasing more carbon dioxide in the atmosphere, right? Well, the ocean is known as a carbon sink. And what that means is that the ocean can absorb a lot of carbon dioxide, okay? Okay, so this is a good thing, right? Because if the ocean didn't act as a carbon sink, we would have even more carbon dioxide in the atmosphere, right? Which would be even worse, right? More global warming or global climate change. But when it does absorb the carbon, it forms that acid, right? So that's what's basically causing that reduced pH. It can absorb a little bit and the pH won't change that much, but because we've been releasing so much CO2 and the ocean has been absorbing so much CO2, it actually now is reducing the pH of the ocean, which is a bad thing because a lot of times the critters in the ocean, their pHs are adapted to a very, very narrow range. And so the pH is basically changing faster than they can adapt to it, especially corals. They have a very narrow temperature, sunlight, pH, everything range. They're really, really sensitive. And so now it wants to do the math. But you see, we've done all the way to part C without any math. So, and let's see. So that was like 3 points on the FRQ. So we've done 3 points already that don't involve math, right? So now it says, in order to model the effects of ocean acidification on coral reefs, some assumptions can be made. Use the assumptions in the table below to perform calculations. Okay, so it says assume global area of corals is 2.5 times 10 to the 11 meters squared. Assume that corals only grow vertically. The average vertical growth rate is 3 millimeters a year. We know that's not right, right? Corals actually they actually grow like this. They're like this. They just grow out like this, right? But we're assuming they grow vertically. We're assuming the density of CaCO3 is 2 times 10 to the 3 kilograms per meters cubed. So right now it wants to calculate the current annual global increase in volume in meters cubed of CaCO3 a year. Okay, so I'm going to actually do this one with the pen, or I'm going to just like not type it because I don't think it'll work as well. But my pen's not working on slideshow for some reason, so I'm gonna have to, yeah. So I'm gonna have to kind of write it with my mouse. So it's gonna be a little slow, but I think it will make more sense. So here's our area, right? Meters cubed, and we know even if we're not really sure what we want to do, we know that our answer needs to be in meters, or we're in meters squared and we need meters cubed, right? So we know we need to do something to get meters, right? So what I'm gonna do is I've got that, and then we have 3 millimeters a year. So what I'm gonna do is I'm gonna take my 3 millimeters a year, and they suggest that you do it all at once, but I don't like to do that. So I'm gonna do it. I'm gonna convert my millimeters to meters, and then I'll put that in my equation up there. So I have 1,000 millimeters in 1 meter. So then we'll have 3 times 10 to the negative 3 meters a year. Okay, and now I can take this and put it up here, right? And so now I'm going to multiply that by, I'm sorry, it's like running so slow. I just didn't think it would make a lot of sense if I tried to write it in a text box. And I'm going to write it like this when I'm doing my math, okay? So now I know I've got meters squared times meters, so I know my units are going to be right. And it's meters 3 per year, which makes sense because it says annual right here, right? So we have 2.5 times 10 to the 11 times 3 times 10 to the negative 3. Okay, so basically we're going to take this 11 and minus 3 from it, and that's going to give us 8. Okay, so then we can do 2.5 times 3. Okay, so you know, you can just do the math. You can do it in your head. You can add it. You can add it up, or you can multiply it. I'm just going to add it up because multiplication is not my strong suit. So that's 6, 7, 7.5. And you know you can't use a calculator on the AP exam either. So they're going to give you numbers that like divide well or add well, you know, that kind of thing. So if you're starting to get like some really crazy random numbers, you're probably not doing it right. Just because they're going to give you things that are easy. And then we'll do 10 minus 3, which is 8. So then we'll have 7.5 times 10 to the 8 meters cubed a year. Okay, and that's our answer. And we'll get credit for this because we showed our work, right? This one actually says you get 1 point for setting up the equation correctly and 1 point for the correct answer. Okay, so you'd only get half credit if you just had the correct answer and no work. Okay. The next part says calculate the current annual increase in mass of calcium carbonate in coral reefs. So show all steps in your calculation. Okay, so what I'm going to do is I'm going to take that number we had last time. Now, let's say part I, you didn't know how to do that. You're just like, I don't know. Go ahead and make up an answer for part I, even if you don't know how to do it. Okay, because what they will do is if you get the wrong answer for part I and you need that answer for the next part, they will actually they will give you credit for that as long as you use it correctly in part 2, right, in this part. So let's say I didn't know what the answer was and I just had like 10, right? I put 10 times 10 to the 10 or whatever. If I use that answer correctly in this part, then I would get this part correct. Okay, so if you don't know an answer, go ahead and make up one and make up an easy answer. Don't make up like 7.99862 times 10 to the 27, right? Make something easy because it's whatever, you're making it up, right? So in part 1 or part I, you would say 8 times 10 to the 10, let's say. And then in part 2, you just put 8 times 10 to the 10 here, or you put 8 times 10 to the 10 in this part instead of 7.5 times 10 to the 8, and then work out the rest correctly, and then you'd at least get a point for part 2. So that's kind of handy. So what I'm going to do is I know that I need my answer in kilograms per year, right, because it's annual. So I have my meters cubed per year, and then I have this 2 times 10 to the 3 kilograms meters cubed. So if I put these together, I should be able to get rid of my meters units and just keep kilograms and years, which is what I want my answer to be in. Okay, so this way I'm going to lose my meters, which I don't want. I'm going to have an answer in kilograms per year, which I do want. And then I can just do my math. So this should be, I'm not very good at writing without my pen. Kilograms per year. Okay, so 7.5 times 2 is 15. And then 10 to the 8th times 10 to the 3. You're gonna add these together. So we have 8, 9, 10, 11. So we have 15 times 10 to the 11th. Now, they'll actually take this, even though this isn't correct scientific notation. If you want to make it really correct, you would do like 1.5 times 10 to the 12. But both of these are actually correct. They'll take both of them. And they'll also take the correct answer not in scientific notation. So if you have 15 and then a whole bunch of zeros, they'll give you credit for that too. Okay, so either one of these would be correct. Okay, and for this one, you get 2 points. 1 point for showing your work and 1 point for having the correct answer. So you'd only get half the points if you don't show your work. Okay. And now we have our third math step. It says, because of ocean acidification, it's expected that in 2050, the mass of CaCO3 deposited annually in coral reefs will be 20% less than it is now. Calculate how much less is expected in 2050 than would be now if the pH is going to remain the same. So basically, we take that number we just got in the last answer. And again, same thing. If you couldn't do part 2, but you're like, man, I know how to do this part, make up a fake answer for part 2 and make it an easy number to work with since you're making it up anyway. And use that for part 3, and you'll get full credit as long as you do part 3 correctly. Okay, so we need to do times 20%, which is times 0.2. So when you're doing your math, and you're actually like calculating it or whatever, you can just do like 1.5 times 0.2, and then see what that is, and then kind of go from there. So I believe it's like 0.3. So then you can get 0.3 times 10 to the 11th kilograms, or times 10 to the 12th, sorry. I'm getting ahead of myself. Try to make this K. And then if you want, since that's not proper scientific notation, if you want to do 3 times 10 to the 11th, that's okay too. You can get credit for both answer. Okay, so either of those would be answer, or 3 and a bunch of zeros to get 3 times 10 to the 11th. All 3 of those answers would be correct. Okay, and then that's the end of the math part, and now we're back at word part. So even if you don't know how to do math, you still can get some partial credit somewhere, because you can do like word parts here. Okay, so here we need to identify a negative environmental impact, and then we need to describe it. Okay, so something negative with losing coral reefs. It could be anything. Since we've only got a couple minutes left, I'm going to kind of go through this kind of quickly. It took me longer to write the math than I would have liked. Okay, so we could say a negative environmental impact. We could say loss of habitat for fish, and then we could say that many fish use coral reefs as breeding grounds, shelter, nurseries, for their baby fish, and losing coral reefs, and that's not going to fit one line, so I'll do it here. And losing coral reefs would reduce the habitat for these things or activities, whatever you want to call it. Okay, you could also mean that you're going to lose biodiversity, or you could say that, coastal areas won't be as protected from storms. You could say you're going to lose that carbon sink. There's lots of things that you could put here. And then it says identify an environmental problem other than one due to ocean acidification that affects marine ecosystems on a global scale. So they actually want something else that's affecting the ocean, but not acidification. Okay, so you can pick anything you want, and you just have to identify it. So you don't even have to describe it or anything. So you could talk about overfishing. You could talk about increased temperatures. You could discuss invasive species, or you don't have to discuss, sorry. You could just say invasive species, trash, plastic. I know some of you guys are actually already working on that Great Pacific Garbage Patch discussion. You could talk about pollution, like oil spills, mercury. Okay, so there's lots of things that are affecting globally the ocean tides, just acidification. So in that one, all you have to do is identify it. You don't have to say anything more about it. So that's kind of handy. So hopefully you got, and hopefully this was a good kind of review for the stuff that we've been talking about on this unit and how you can kind of apply that information to an FRQ. And also hopefully it showed you kind of how specific some FRQs be, like the one where they wanted like the chemical equations and all that detailed stuff. And also you can see that even in a math problem, there's still lots of things that you can get points for, right? Like this part E, is fairly easy, and it was on a math part. So just because you see numbers or math or something like that on an FRQ, don't just automatically like skip that one and not even read it if you're not very good at math or whatever. At least read the rest, because sometimes there's usually the math is at most about half of the FRQ, so there's other places where you get points. For this one, I think it was like 6 points. So you could at least get 4 points, even not doing the math, which 4 points is, nothing to sneeze about. That's 4 points, right? So anyway, hopefully that was helpful with FRQs. I think we have like 2 more of these type of subject-based reviews left, and then we'll go into the reviews for the final exam and the AP exam, and then, which this kind of was an AP review a little bit, and then we'll be done. So we've got like, I think 5 sessions left before the end of the semester. So we really are kind of on the downward slope. So hopefully that was helpful. If you have any questions, I would love to answer them. Otherwise, you're free to go. That's really all I have for you. Oh, if you skip a question, is it okay to leave space? Yeah, totally. Just leave space in your answer book for the question that you missed or that you skipped. Usually they give you like a few pages per question. So I want to say maybe like 8 pages total, like 4 front and back. So just like skip one and go to the next one, and then just leave some space for that. And then you can always come back to it. Or you can, like for this one, let's say you want to answer all the FRQs and then come back to the math and kind of struggle through it or whatever. If you weren't really sure how to do it, you could just leave space for like just the math part, and answer part A, B, skip C, 1, 2, 3, and then go to D and E. So yeah, you can just leave space for it.